So as I mentioned, this is Module 3 of the Software Testing Fundamentals course. In this Module 3, we'll talk about creating software tests. We'll go into user-centric tests. We'll talk about software testability. We'll go into creating a test plan and the components around that. We'll talk about feature testing. And then we'll also talk about scoped test cases and how we appropriately set those up. So let's go ahead and move forward. So in this modules, I talked about user-centric testing, software test, creating test plan components, feature testing, appropriate scoping test cases. In this section, we'll talk about the user-centric testing and also test-driven development. This section will cover business needs and issues, customer requirements and scenarios. We'll also talk about testing hooks and test-driven development. So with each module, we have guiding questions. Our first question is, what is an example of user requirements documents? And then we'll answer the question, what is the advantage or benefits of test-driven development? And then finally, what type of testing is central to test-driven development? User requirements. Eric, you and I have talked about user requirements before. Very key, very important part of beginning software development, but also critical to tests. So can you give us some kind of insights in regards to how you look at user requirement documentation or diagrams?
Yeah, so the user requirements are going to be, obviously the business people are going to be heavily involved in crafting those, and they're going to be in the form of a user story or use case diagrams. Okay,
all right. And when you think about these use case diagrams or user stories, how do you manage those? What's the best way to manage those
So those are all handled in Visual Studio and TFS.
Oh, cool. All right. Well, I think we'll talk about that a little later.
Yep.
Okay, great. So use case diagrams are kind of a graphical way to look at how the user will use the system and what they'll use it for. Use case really represents the goal of the user and the procedures they'll use to achieve those goals. We've got a very easy and simple use case diagram here. We have a customer and we also have a restaurant. Those are really kind of our two users. Eric, you want to kind of pull us through this diagram?
Yeah, so this shows the goal that the business user is setting out for their application, their need. Their need is they have a customer and they want their customer to be able to buy a meal, which includes ordering it and paying for it. They've got a restaurant. They need that restaurant to be able to update the menu and deliver the meal to the customer.
Pretty simple use case. Easy to pull the graphics into this.
And you'll notice specifically the implementation, the technologies behind that are not included.
Okay. So as we think about the user story is kind of like that next tier down, being able to talk about the functionality of those different steps. Each user story should state only one activity a user wants to complete at a time in the software, and really to describe that from a user's perspective. Now we talked about Visual Studio and how the use stories and also the diagrams can be put in here. Talk a little bit more about that, would you?
That's right. That's just part of Visual Studio, and it's really handy. You can get those user stories right into Visual Studio. You can have your test tasks associated right to those user stories, and your test cases are associated to your tasks. So everything is traceable back both directions, so you can see how your user story is being tested, and you can validate if a user story even changes down the road. You can very easily trace back and figure out what test cases does this affect, what test cases do I need to change, or what test cases do I need to rerun. And that's all handled in Visual Studio.
So it basically does the tracking, so if there's any type of change to that user story, it will go ahead and track that change?
So that's right. When you enter your test work item, which is going to be to test against a specific user story, that is linked in Visual Studio.
Oh, that's cool.
So you've got a link in there, and then when you write your test cases against those, you've also got that linked as well.
Excellent. Great. Yeah. Useful tool. So let's talk about a couple of user story examples. One, if you think about the customer itself, one, they want to be able to view the current menu. Second, the customer may want to place an order. Third, they want to pay for a meal. So this user story aligns with that user diagram pretty succinctly. Then if you think about it from a restaurant perspective, you want to add an item to the current menu. You may also want to delete an item from the current menu, but that's not in here. So we wouldn't identify that as being a part of the user story. And then also the restaurant wants to be able to deliver the meal. So those are user story examples. Very simple, very easy, but very important as you think about truly understanding the requirements of the customer. So next we're going to talk about test-driven development. Test-driven development is really a technique that uses the unit tests to guide the software development and the design of that, or design of software and the development activities. It requires you to develop test cases before you develop the code. Developers then develop the functionality to pass the existing test cases. Eric, can you give us some examples?
Yeah, in this case, the developers are writing the test cases before they write their code, and that's central to test-driven development. It's heavily automated, if not 100% automated.
Okay. And you use these test cases as documentation. Again, these are a part of. Is it Microsoft
right.
Test Manager? They use
These
this?
are going into TFS.
Okay.
These are all included. All these test cases are documented.
Oh,
in the
excellent.
code.
Good.
Right.
That's great. So pull us through a test-driven development process.
Right. So the test-driven development process. Here's the very basics of it. The developer creates the test code. They write or modify the functional code. If the code was already in place, they're modifying it based on their test cases. Creating additional test cases as they're going. So, ideally you're creating all your test cases before, but you're always thinking of new ways to test once you're writing this code. So they're writing the additional tests, and then they're testing that functional code, finding bugs, going back through, iterating that process many times until it's totally clean, and then they're rolling that out.
Okay. All right. So the next topic is testing hooks. These happen to be ways to allow for internal functionality to be tested that's independent of the rest of the software. So you may have a block of code that you want to test. Leveraging testing hooks is a key part of doing that. Eric, how much do you use testing hooks as a part of your testing process?
Yeah, we
today?
do. This is just part of normal practice now. So we do quite a bit of this, and these hooks are going to allow us to test things in a much easier way that were much more difficult to get to. For example, just skipping a bunch of the prerequisite steps to get to a certain area in a product.
Okay, all right. And I've been told that these may also be left in code once you release it.
Yeah, you can leave the test hooks in. You may want to run your automated code in production once it's deployed. And there's no problem with that.
Okay, great. So give us some additional examples that you can think of in regards to test hooks.
Yeah, sure. There's simplified user interface, allowing streamline access. We're talking about, I want to get to an admin screen that's going to take a certain set of user permissions, or it's going to take us a bunch of clicks to get through. I don't necessarily want to do that every time through my automation, so I'm going to be able to jump right into that.
I think command line is quite interesting also, as you think about those people that leverage command line arguments and to do some of their work. Being able to kind of bypass the UI, but going directly into, the code and executing command lines That's really where some hooks really play a role too. So we have our section questions. Eric, so what's an example of a user requirements document?
So these are what we just talked about, use case diagrams and user scenarios.
Okay. And what's the advantage or benefits of test-driven development?
In test-driven development, the test cases are used as the documentation, and there's a heavy use of automation.
Okay. And then finally, what type of testing is central to test-driven development?
Those are the automated unit tests.
Okay, great. So now let's move forward to 3.3, creating test plan components. In this section, we'll cover the following. We'll talk about test schedules. We'll talk about scope. We'll talk about methodologies. We'll discuss different scenarios and also key tools. So as we talk about for each module, we have a number of guiding questions. Our first question is, what does ALM stand for? Next question is, what software is the centerpiece for application lifecycle management in Microsoft Visual Studio? And then the final question is, what is code coverage? So let's get started. Application lifecycle management. We've talked a lot about this in our previous modules. It really refers to the administration of the entire scope of work that's done to build an application from planning to maintenance to from planning to through deployment to maintenance. So pull us through a application lifecycle management environment.
Okay, so this is an agile project here that we're highlighting. So you see the blue stack there, and that's the whole backlog. So you take an arrow to the right there, you go to plan a sprint. So like we mentioned before, you're in Module 2, you're picking whatever fits into that sprint. Say your sprint is 2 or 3 weeks. You're grabbing your 3 items that you want to include with that. And then you're running your sprint, and you see the small circle up top, which is your daily cycles. You've got your actual dev work that's going on. Now you're going to completing the dev and test cycle there in your time frame, deploying to your stakeholders, and then you see the arrow straight up, which is ask for feedback. That's your retrospective is included in that, and that's also the time when you're getting feedback from your users. The feedback is the users saying, here's what I really like about this, now here's what I want as well. Those items get added to that backlog and prioritized, and then you're off to the races in your next sprint.
Okay. So now let's talk a little bit about testing strategy and scope. So as we talked about before, as early as possible, developers need to discuss and establish a test strategy for the project. Now, it really all depends upon the methodology that you use, whether or not you're using Agile or whether or not you're using Waterfall and how that test strategies work. It also is, once you define whether or not you're using Agile or Waterfall, the way the teams engage are a lot different also. Each plan would have its own scope. Can you talk a little bit more about those, the scope of these plans?
Sure. So in the Waterfall methodology, the test plan is going to include everything for the project end to end. In the Agile, it's going to include whatever is in that 2-week sprint.
Okay. Code coverage really is all about understanding how much of the project code has been tested. So you can do that both at a block level and a line level. Can you talk a little bit more about those two?
So the block coverage is just if a code block is touched by the automated code, then it counts that code as being included in the covered areas. And in the line level, it's just line by line. So the development team is going to set some goals at the beginning of the project of how much of their code that they're going to hit, and they're going to be held to that standard.
So 80% is usually the standard that many people strive for. What I'm hearing is you probably strive for a higher number. Is that correct?
I think 80% is an industry standard, and I think that's a legitimate number. 100% code coverage is talked about, but I don't think the value add is not there, and it's difficult to hit that, and it really doesn't give you what you need.
Okay. All right. So our section questions. First, what does ALM stand for?
That's Application Lifecycle Management.
Great. And what software is centerpiece for ALM in Visual Studio?
So that's TFS, so that's Team Foundation Server, and that includes tools for the manage of requirements, design, development, test, change management, release management, maintenance, program management.
Now, does TFS come with Visual Studio, or you buy that separately?
That's a version of Visual Studio. So
Okay.
Visual
Yep.
Studio Team Foundation
All right.
Server.
Okay. And then code coverage.
Code coverage is measuring the ratio of code that is touched by your test or that it's not.
Okay. All right. So let's go ahead and move on to section 3.3, feature testing. In this section, we'll talk about the appropriate feature tests. Our guiding questions for this module is, what is a feature test? Who should be the focus of a usability test? And then finally, what name is used to describe an automated test of the user interface? So software features. A feature is a capability available to a user, similar to like what we see with Microsoft Word being able to underline text. That's a key feature. Features are determined largely by the user stories that are created for the initial planning process. Many features may overlap the functionality of the code. For example, a same project may also accept other forms of payment. When you think about a credit card payment type of application, they may use that multiple times throughout the application.
That's right. And when thinking about features, you have to think, how do I test this feature? And then how do I test this feature in all the ways that this feature is meant to be used? Because in most cases, a feature is accessed in many different ways.
Okay. So let's talk a little bit more about feature testing. So you have well-designed units and integration tests that provides some really good code coverage. It also helps to ensure that the work units meet the specifications of the developers. It's also important that the functionality of each feature is tested. When you think about the big picture goal of feature testing, really what is that?
Well, the big picture is that the feature meets the user's need. It meets the requirement that was laid out.
And when you think about this type of feature testing, is it either white box or is it black box testing?
Now, the feature testing is black box testing.
Okay. Next, exploratory testing. I kind of like the name exploratory testing. It's also called ad hoc testing. This is where you provide a test scenario that where the user can experiment into certain areas of the UI or the application itself. When you think about this, what are some of the challenges that you see, Eric, with exploratory testing?
Well, some of the challenges are getting complete testing and making sure that the person doing the exploratory testing understands what the expected results of the test are, because that's very important. Is before the test is completed, you really need to understand what you expect the test to do, so you can write a valid bug and you can get that to the development team quickly and get that analyzed and get that fix in place.
So next let's talk about usability testing. This really involves the study of how the end user interacts with the software. We talked a little bit about UI testing in the previous module, but let's talk about it from here. So as we talked about usability tests, they're usually black box tests. This type of usability testing provides valuable feedback for the related ease of use and also customer satisfaction. Although usability tests are really not necessarily a part of a feature test, but it does explain how the user operates a specific feature of any given application to be able to expose any flaws. Next is the UI test. Any test of the operational functionality of the user interface is considered a UI test. We've already talked a little bit about this too. So we just finished this part of Module 3. Here's our section questions. First question is, what is a feature test?
That's a logical grouping of functionality that you're testing.
Okay. Who should be the focus of a usability test?
So the focus of the usability test is the end user.
Okay. And what name is used to describe an automated test of a user interface?
That's coded UI.
Coded UI test. Great. Let's move to 3.5, which is the appropriately scoped test cases. In this section, we will review appropriately scoped test cases. We'll talk about boundary conditions or bounds, as you've put that before, Eric. We'll also talk about level of detail and validity. So here's our guiding questions for this section. What is a boundary test? What is a happy path test? And then what type of test is generally requires detailed steps? So we'll start off with test case design considerations. There's a lot of permutations of an application's data, and the possible paths through the code are very large. When you think about these design considerations, what are some of the things you need to be thinking about here, Eric?
Well, I think the most important thing in your test case design is designing the test cases and selecting what you're going to spend your time on the highest value add. So what test cases are going to find me the most bugs, and what test cases are going to find me the high value bugs, the really bad bugs.
Now, we heard of the happy path test cases, and I kind of have to laugh because I've never heard it called happy path test. So talk a little bit about this and what happy path really is.
So these are the positive test cases.
Okay.
And what that means is, does the application work as I expect it to? So, or does the feature work as I expect it to? So if the user does everything you think they're supposed to do, they're highly trained, they don't try to mess with it, they just put in the exact data you expect, that's a positive test case, or what's referred to as a happy path test case. On the other side, there are negative test cases, which is just the opposite. Is this user going to come in, what if they put something in that I don't expect? What if they have a hyphen in their first name that I didn't really take into consideration? Things like that. Those are your negative test cases.
Okay. Zero and null cases. This is pretty simple and easy to think about. I mean, in the case of numeric data, you also have to test on handling zero values. As you think about nulls, when you have strings that have no data in there, you also have to test against that. Now let's talk about boundary tests, or bounds, as you put it, and give us maybe an example of what a boundary test is.
Yeah, so boundary testing and just thinking about these edge cases is really what helps you categorize and reduce the amount of test cases you have to write. So if you think about an example of, you may have an entry field that allows the numbers 1 to 100. Now, as a test person, you may think, well, I need to test every number here. I've got 100 test cases I need to write. But really, your bounds cases are thinking about the boundaries of that entry field, which are the number 1, the number 100. Those are your bounds. Now, other cases are also the number 0, the number -1, and the number 101. Now, instead of writing 100 test cases and actually missing the important ones, which are actually 0, -1, and 101, you're going to write 5 test cases, and you're going to really hit all the boundaries. If you don't find a bug in any one of those 5, you've really hit the most highly likely place that you're going to find a bug.
So this is really, so when we think about the design of our test case, this is very important to truly understand because you don't want to spend a lot of time doing a lot of tests. You want to understand exactly what the parameters are and understanding the logic around those parameters so you're being as effective as possible whenever you're doing these tests. So let's talk about manual test cases for a second. You know, we've talked about them before in previous modules. It can be, you know, these manual test cases can be executed by different testers at different times. It's important that they include enough detail to ensure consistency. They're broken down into discrete steps, each with a description of the action and expected result. Now, with Visual Studio, you can do some really kind of creative things with manual tests. Can you talk a little bit about that?
Yeah, that's right. I mean, you can attach files to your manual tests. They can have additional details. You can add screenshots to it. You can do a lot with Visual Studio.
Okay, cool. Here's some manual case examples. You want to kind of walk us through these, Eric?
Sure. An example, click the sign-in link in the upper right corner, enter your username at the prompt, type your password, click the sign-in button. The thing that's missing here is your expected results. You want to have that listed as well.
Okay. Exploratory testing. This is where the development team sometimes supplies or supplements detailed testing with a more of an exploratory approach, basically just kind of giving them a part of the application. Then they are able to move their mouse, click on things that may or may not be a part of the initial, what they're looking for test results, as we've talked about before.
Right. So we'll do this exploratory testing. We'll do what's called a bug bash, and we'll invite 20 people into a room. We'll give them all lunch, and we'll say for the next hour, we want you all to log into the site, and here's the 4 things we want you to complete. And the really fun thing about that is, especially at a software company, people really, really want to show bad behaviors. So you're going to find a lot of bugs in a really quick amount of time. They understand that they need to keep it within a certain scope, do the testing, and you're going to get a lot of value out of this exploratory testing.
Next is user interface testing. Again, we've talked about this before in previous modules, but when we think about the UI tests, it's really the operation and functionality of the user interface and testing against that. Now, we talked about this being very critical to driving customer satisfaction and success. Tell us a little bit about what Visual Studio does to help with this again.
Yeah, so we talked about coded UI. I think that's a really important feature to look into and to practice and to get familiar with.
Okay. So let's finish up with our section questions. First question is, what is a boundary test?
So those are your edge cases like I talked about. You find the distinct edges of the data that you're expecting, and you go above and below those edges, and you hit the kind of sweet spot too, and then you can really reduce the amount, the number of test cases you need to run.
Okay, and a happy path test or a positive test?
Yeah, that's your positive test cases. You're following the intended path.
Okay, and then what type of test generally requires detailed steps?
Detailed steps, those are your manual tests, and when you're writing your manual tests, you really have to assume that the person that's going to execute your manual tests may not have a lot of experience in the space that they're going to be testing. This could be a contingent staff person that you're bringing in just for your test case execution.